Welcome to Pick Computer Science video number 4, where we take another look at the little man computer, and this time how it can do addition and subtraction. So here's our little man computer instruction set. So we're going to be utilizing the mnemonics add and sub and their equivalent machine code, along with some of our other commands to make this addition and subtraction happen. So this is the actual machine code that I'm going to be loading into the little man computer this time. So away I go, file open, find the right program that I want to load up. That's the machine code that we just looked at, 901 306 901 106 902. If you think back to our instruction set, just pause the video at this point and have a think about what those instructions are going to achieve. And what they're going to achieve is this. 901 is the machine code for getting the user to input a number, and 3 is the machine code to store a value, and it's going to store the value input by the user in address box mailbox 6, which is currently 000. Incidentally, it's not our first mailbox that is 000, and there's a good reason why we're not storing something in number 5, so have a think about why that would be. We're actually going to store it in 6. Then it's going to ask for another number to be input, and then it's going to use machine code 1, which is the add instruction, and it's going to add whatever's in the accumulator, so the value that has been input second, to the value that is in mailbox 6, and then it's going to output that value, so it's going to add two numbers together. So I'm going to step through the program and see what it does, and the first thing it's going to want to do is grab some input from the user, and it stores that into the calculator, the accumulator. The next thing it's going to do is store the value from the accumulator into memory address 6. So it got to go and grab the value, and it pops it into memory address 6, as we saw there. And as I step through the program, it becomes more apparent to me that everything is focused on the calculator, on the accumulator. Anything that's input by the user goes into the calculator. Anything that we want to store in a memory address comes from the calculator. It's only the values in the accumulator that can be stored. If we want to load up a value from a mailbox, then it is loaded up into the accumulator. And if we want to output a value to our user, it's the value in the accumulator that can be output. So everything is focused on that. All input, output goes through the accumulator as per our definition of the accumulator register. Continue to step through. Then next thing it's going to do is ask for another number to be input. So I'm adding 23 to 24. 24 goes into the accumulator this time. Remembering I've got 23 saved in mailbox 6 ready to do the addition. Now it's gone to do 106 as an instruction, which is add the value in the accumulator to the value stored in mailbox 6. So we should end up with our answer of 47. And that goes into the accumulator. And the last thing it's really going to do is going to be to output that. 902 is to output the value in the accumulator. And there we go, it's output to the user. One last thing the little man computer needs to do is go and read memory address 5, which is 000, which was why it was left as 000 all through the program, because that is our instruction to halt. Incidentally, here is what the assembly language code, the mnemonics for that same program might look like. It uses the mnemonics, it uses things called labels, and labels you must assign to a mailbox. So you can study this. You could load this code up into the Durham Uni LMC compiler, compile it, and it should give you the same machine code that we've just used. Here I've got some machine code with some more instructions than the previous program that I've run. And this is because this program is going to add up 3 numbers that are input. So I've got that machine code loaded up into my mailboxes. And I'm going to step through it to see these 3 numbers being added together this time. So first thing, it's going to ask for some input. Pop in the number 3. Stores that in the accumulator. And then it's going to store it in a memory address 9, so we should expect 3 to pop over into that memory mailbox there. There it goes. We're going to input a second number. And the next instruction is our 1 instruction, which is to add the value in the accumulator to the value that's in address 9. So we've got 4 in the accumulator, 3 in address 9, so it's going to come up with 7, and it does. And then the next instruction is again to store that new value in address 9. Now address 9's got 3 in there already, so that's going to be wiped, and 7 is going to be popped on top of it. And this process is repeated once more. Until we end up with our final answer of 12, which is output there before, you guessed it, halting. Here we've got the assembly language, which would compile the same machine code for adding up those 3 numbers. Notice that we've got more lines of assembly language, and we've got our mnemonics, and we've got our operands, which are labels, basically point us towards our 10th mailbox, mailbox number 9, which is where values are stored, are loaded from, and added to the values in the accumulator. And we need to interact with that mailbox 009 more times than we have done previously, hence we see the operand there 4 times instead of the number of times we saw it in the last program, which was fewer. At this point, I'll just mention a couple of tips for using this implementation of the LMC. If you want to continually run a program time after time, maybe to test it out and change it, it's important that you reset all after each run of a program. That'll clear down any outputs, it'll clear down any values in registers, so let's do that. It won't clear down any mailboxes in this implementation, any mailboxes that have been had data stored in them whilst the program has been running, so you might want to manually clear down any of those just to avoid any confusion. Another thing to think about is inputs can be stacked up and used automatically rather than entering them into the input box each time. So if I wanted to use the inputs that I used in the previous run of that program, I could do something like that, and then hopefully, yep, the whole thing runs for me without me actually having to input manually as the program is running. This machine code makes use of the to instruction, which is for subtraction. So let's see how that goes. So this machine code has been loaded up into my mailboxes with the all-important to instruction to do a subtraction. So let's check it out. Input a value. Store it in mailbox 6. Input another value. So I might put a number that is smaller in the hope that that number can be subtracted from the original. So 3 should be okay to subtract from 4. So now I come to my subtraction instruction 206, and what that is actually going to do is subtract the value that's stored in mailbox 6 from the value that's in the accumulator. That's what 206 means at this point. So we've got a problem. Let's see what problem occurs. We should end up with a negative number. 3 take away 4. Let's watch. We don't get a negative number. We actually get the value 999 in there, but we do get a negative flag. That's the little red minus sign to the right hand side of the 999. So something's gone wrong. And if you read the notes on the Durham Uni LMC implementation, it does state that subtraction, which results in negative values, isn't handled by this implementation. So let's just finish off the cycle of this program and see what it outputs. It outputs 999, which of course isn't correct. It then, of course, halts. So the way around this with this program, if I just reset everything, would be to enter the smaller number first, to end up with the correct result, which doesn't seem too logical. A better solution would be to have our program store both numbers into memory addresses using the instructions in mailboxes 1 and 3 there, and then performing a subtraction from the number entered first using the number entered second, so A minus B effectively. So let's watch this one happen now, and let's keep your eye on it and see if you can figure out what it's doing. Larger number first should be stored in mailbox 8. Smaller number second should be stored in mailbox 9. And then we load up things in the correct order to get the correct output. And here's what the assembly language for that subtraction program might look like. And notice that we now have 2 different labels, so we can store 2 different numbers in some of our later mailboxes, so that we can grab one of them and subtract the number from the other one. So that's why we have 2 different labels in this assembly language. So some simple addition and subtraction there with the little man computer. In the next videos we'll look at how it can do some more serious algorithms, including iteration and selection. So bye for now.